In this video, I'm going to talk about what a derivative of a function is. So the derivative of a function y equals f of x is the measure of the rate at which the value y of the function changes with respect to the change of the variable x. So that means the derivative is the exact value of an instantaneously changing rate of a curve. So for example, if you were thinking of a sprinter and you wanted to know the exact rate of change at a certain time when they were running, that would be pretty much what a derivative is. It's the exact value of an instantaneously changing rate. So now we're going to be talking about derivatives, looking at it graphically. So the way we get the equation is straight from the graph. It would be the slope, the classic slope, rise over run. So we would gather the x values and the y values. So the equation that we use to find the derivative of a point would be x sub 0 plus h minus f x sub 0. So the way we'd get that is from this point right here, x sub 0, we would gather the y values, which would be x sub 0 minus x sub 0 plus h. Same with x, which would be the run, would be x sub 0 minus x sub 0 plus h. When those values, x sub 0 would cancel, leaving it to just be h. We can get 2 points to get a secant line to see roughly what the derivative of this curve would be, but the just straight derivative of a point would be more closer to this green line. So the graph will give us the equation that we're looking for. One quick thing to go over is where derivatives do not exist at. So they want to exist where the function is not continuous. So for example, here's the function, it goes down and then stops and then continues up here. There wouldn't be an existing derivative with a function like that. Another function where derivatives don't exist is corners or cusps. So the derivative, or this function, comes up in either corners or cusps, and so then the derivative wouldn't exist. Last but not least is vertical tangents, where the function is vertical, but you can't get a derivative from a function like that either. So now we're talking about solving the derivative of a point algebraically. We're going to be using this equation, which means as the limit h gets closer to 0, the function x sub 0 plus h minus f x sub 0 all over h. So we're going to do an example of this equation right here, x squared plus 1 at the point 2, 5. We're going to try to find the derivative. So wherever we find an x in this equation, we're going to substitute this to the x value, which you see right here. Then we'll put these values back into this equation, which would be 2 plus h squared plus 1 minus the f function x sub 0, which is 5. And then after foiling it out, we would get 4 plus 4h plus h squared plus 1 minus 5. And after doing some math with the constants, it would end up being 5 minus 5. I'm going to get rid of those constants. And it would end up being 4h plus h squared over h. From there, we would want to factor out the h's. And then we could cancel these h's, which would leave us with 4 plus h, where we want to be, because then as h gets closer to 0, we want to know what that value would be, so we could just substitute 0 in for h, so it'd be 4 plus 0. So the derivative of the value 2 would equal 4.